In this tutorial, we will be discussing alkanes. Alkanes are hydrocarbons, which remember are just hydrogen and carbon. They contain only carbon-carbon single bonds and carbon-hydrogen bonds. They are formed by a continuous chain of carbon atoms. And you're going to have to try to find the longest of those chains in a row, longest amount of carbons bonded to each other, to determine what the name is. Speaking of naming, these are named by IUPAC. That's how you say that. International Union of Pure and Applied Chemistry. They all end in ANE. That's also important because as we add in double bonds and triple bonds and other names, you're going to realize that ending changes. We use Greek prefixes to name the carbon chains with 5 or more carbon atoms. Look at this list very carefully. You are going to have to memorize those. Meth is 1 carbon. Notice that there's only 1 carbon here. Eth has 2 carbons. Prop is 3 carbons. That's pronounced bute. It's a long U. It's 4 carbons. Pent, hex, hept, oct, nona, and dec. Those are your prefixes you're going to use when you're naming these alkanes. The condensed structural formula is showing you the bonds in a shorthand method. So we know we have 3 hydrogens coming off of here. We have 2 hydrogens coming off of here. In the previous tutorial, remember, each carbon has to have 4 bonds. That's super important, and this is why. We have a carbon-carbon bond here, so this carbon and this carbon is bonded together. That's what this is saying. We have 3 hydrogens coming off. Here we have 2 hydrogens coming off. Hydrogens are kind of taken for granted in this process because they're automatically there even if they're not written. You'll see that when we start doing skeletal structures. Alkanes are written with structural formulas that are expanded to show each bond. So here's the structural formula. We can actually condense it down so we don't see each bond. So instead of saying C with these 3 hydrogens, we can just say CH3. Instead of saying C with these 2 hydrogens bonded, we can simply say CH2. It is known by the reader that those hydrogens are coming up and down. These are the skeletal formulas I was just talking about. This is not typically written in skeletal structures. You'll have to know that every time the line ends or every time the line bends, there's a carbon there. And this is where those 4 bonds come in handy of knowing that. So we have 2 bonds here already written. We have 1 to this carbon and we have 1 to this carbon. Because we have to have a total of 4, we automatically have 2 more bonds here going to hydrogens that are not written. Remember, hydrogens are taken for granted. Chemists have a tendency to get annoyed with writing them all the time. So they just leave them out altogether. So molecular formula gives us the total number of carbons and hydrogens. So if I were to do the molecular formula of this, I would say 1, 2, 3, 4 carbons. So C4, then 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. That's the molecular formula. The skeletal formula, this is all you write, is this zigzag. Because the 4 carbons are represented here, 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 and here. And then the hydrogens you have to figure out by counting how many lines you're missing of the 4 that you need. So conformations of alkanes. Carbon atoms in a chain are connected by single bonds. These move freely. They can rotate around. And so because of that, see the CH3 is up on top here. It can actually move to the bottom here. And that's called the conformation as to where it's angled at. Alright, so there's several different ways you can write these out. We have the simple molecular formula where you just say what it is. We have the ball and stick, which is essentially models. Expanded structural, where you draw every single line. condensed structural, where you just write the hydrogens, and then the skeletal, where you don't write any of the hydrogens in. You just know that there's 1, 2, 3, 4, 5, 6 carbons there, and then you have to figure out how many hydrogens are missing. I wanted to show you this picture because of this area here. These are all the same compound. No matter what, this is butane. There's C4H10. Notice when it bends, it's still considered butane. This is where a lot of students get confused. When they say in a straight line, they look at just one area. So for instance, they might look at this and say, okay, that's the straight line. But in reality, what you want to do is figure out which one has the most carbons connected. So that's considered part of it because there's a connection here. This gets very important towards the end of this chapter when we start talking about substituents. Alright, so let's do some practice. First of all, let's figure out the molecular formula of this. We have 1, 2, 3, 4, 5. So we have 5 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. The condensed structural formula, we're going to take all these hydrogens and condense it down to CH3. This becomes CH2. This becomes CH2. This is CH2. And then finally, this becomes CH3. And that's your condensed structure. The compound name, we have 5 carbons in a row. 5 is pent, so it becomes pentane. The condensed structural formula of ethane. Eth means 2 carbons. So we can draw this out. Here's our 2 carbons. There's 4 lines coming off of each carbon. Here's 1, 2, 3, 4. 1, 2, 3, 4. And we're going to draw hydrogens at the end of each of these. Notice how when we named it, we didn't even look at the hydrogens. So this is the structural formula. To make it the condensed structural formula, we need to take away those bonds. So CH3 dash CH3. Let's try another one. Heptane. Hept means 7. So 1, 2, 3, 4, 5, 6, 7. Each carbon gets 4 lines. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You'll notice that it seems kind of redundant to say it over and over and over again. I'm doing it just that way. I'm trying to spell it out really, really slowly for you at first because this is laying the foundation for the rest of the semester. If you can't figure this part out, you're going to be struggling until the end of the semester, and I don't want that to happen. So all these lines here that go nowhere have hydrogens at the end. So we can condense that down into a condensed structural formula. CH3, CH2, 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 and then we have one more CH3 at the end. Let's double check that. 1, 2, 3, 4, 5, 6, 7 carbon. So we're good. Cycloalkanes are cyclic alkanes. So in other words, they turn into almost like a circle. What you'll notice about these is they tend to make geometric formations. You can kind of see a shape out of it. You're going to start the word with cyclo. So we're taking away 2 hydrogens. So this becomes a CH2, this becomes a CH2. that dot or that line that we're missing now gets connected. And so in this particular one, it turned into a triangle. 3 sides, there's 3 carbons here. Here's some, just some basic ones. Cyclohexane, there's 6 of them. 1, 2, 3, 4, 5, 6. There's the condensed structural. Then notice how it makes a geometric shape of a hexagon. So that might help you with naming it. So let's do a review of just naming. IUPAC of these. 1, 2, 3, 4, 5, 6, 7, 8. 8 is oct, so it becomes octane. This is a pentagon. So we have pentane here because there's 5 carbons. 1, 2, 3, 4, 5. It's cyclo because they're all connected. One last screen. 1, 2, 3, 4. 4 is bute, so it becomes butane. 1, 2, 3 is prop, so it becomes propane. Because they're all connected, it's cyclopropane. 1, 2, 3, 4, 5, 6, 7, 8. 8 is oct, so that becomes octane. Then 1, 2, 3, 4, 5, 6. 6 is hex, so that's hexane. Notice that they all end in ane. That's because they're all single bonds. And we're going to put cyclo in front of that because it forms a geometric shape. It's all connected. And that is your beginning of how to name alkanes.